We have also the exterior angle inequality theorem. We've already discussed the exterior angle equality theorem, but for the exterior angle inequality theorem, it says here, let's say for example, we have here this chair. Okay, so it's a common chair that you can see in the sofa or also on the outside in the swimming pool in the on like backyard. Okay, so you can see here a reclining chair, okay, that has an armrest, and then under the armrest there's a triangle there. So let's try to draw the triangle here. We have here angle A, and then we have your angle B, angle C, and angle D. Okay, so according to the exterior angle equality theorem, the measurement of angle A should be equal to the sum of the two remote interior angles that we have here. So that's gonna be measurement of angle C plus the measurement of angle D. According to the exterior angle inequality theorem, so it says here that the measurement of angle A should be greater than the measurement of angle C. That's the first supposition. And then for the second one, we have the measurement of angle A should be greater than the measurement of angle D. Okay, so this is very useful when you're trying to measure certain objects and you want to create conclusions about their angles, okay, for the certain objects that you're measuring. Let's say for example you're an engineer or a carpenter. Okay, so this is a very useful theorem that you can use. So there you go. Always the exterior angle is greater than one of the remote interior angles for this one. Okay, so first we have so that's the exterior inequality theorem for this one. But let's try to create a problem. Okay, let's say for example the measurement of angle A is equal to 115 degrees. So what are the possible measurements of angle C and angle D for this problem? So solving this problem, okay, yeah, we know that the measurement of angle A is equal to 115 degrees. To get the measurement of angle B, we're going to use the linear pair postulate. Okay, so linear pair postulate. Okay, so why are we going to use that? Since it's a straight line, so therefore the measurement of the angle of a straight line or straight angle is 180 degrees. So therefore we just have to subtract 180 and 115 to get the measurement of angle B. Okay, so therefore the measurement of angle B is gonna give you 65 degrees. So therefore the measurement of angle B is 65 degrees. So what are the possible measurements of angle C and angle D? So we know that the measurement of angle C plus the measurement of angle D should give you 115 degrees based from the exterior angle theorem, the one that we've learned during the first quarter. But we're asking here what are the possible measurement of angle C and angle D. So therefore the measurement of angle C should be less than 115 degrees and the measurement of angle D should also be less than 115 degrees. It cannot be greater than 115 degrees in order for us to create a triangle for this type of problem. Okay, so for the inequalities of one triangle, so we have two theorems here. We have the side angle inequality theorem and then we have the angle side inequality theorem. So in concrete terms, how does the side angle inequality theorem play? Okay, let's say for example we have your triangle ABC. Okay, and then we have here a side measurement. Let's say for example this is this is B. Okay, and this is side A and this is side C. Okay, for this one, if one side of a triangle is longer than the second side, okay, so let's say for example that B is greater than A. So if B is greater than A, according to this theorem, then the measure of the angle opposite the longer side is going to be greater than the measurement of the angle opposite the shorter side. So therefore the measurement of angle B should be greater than the measurement of angle A for triangle ABC using the side angle inequality theorem. So let's try to apply that theorem and let's try to prove it. using this triangle that we have here. We have triangle FIG, okay, with line segment FQ on the triangle, okay, and point Q lying on segment IG. And also, for this one, we're supposing that IG is greater than FG, okay, given here from the side angle inequality theorem uh, for that problem. Okay, so we want to prove that the measurement of angle IFG is greater than the measurement of angle G using the side angle or the longer side theorem. Okay, so for our first statement, we're gonna say that we have to draw a segment there. So draw segment FQ such that IQ is equal to IF. And the reason for that is going to be the ruler postulate. It says that on a line, we can draw any line segment that connects the two points that we have on a given geometrical figure, or points on a line can be assigned real number coordinates. And then for our second statement, we have IQ is congruent to IF. So this segment right here can be congruent to this segment right here using the ruler postulate. Deliberately we created a segment that's going to be congruent to IF, and that's IQ. And then for our third statement, we can say that angle 1 is congruent to angle 2. Okay, so that's going to be the isosceles triangle theorem. And going forward with that proof, so we have your measurement of angle 1 is going to be congruent to the measurement of angle 2 based from our statement on the third, based on our third statement. And then for our fifth statement, we have here the measurement of angle QFG. Okay, so this is this angle plus the measurement of angle 1 is going to give us the measurement of angle IFG. Essentially, you would want to get the measurement of this angle because we're going to use that on our proof. And from our proof, we can say that it's going to be greater than the measurement of angle G after going over with some parts of our proof here. So therefore, the measurement of angle IFG is greater than measurement of angle 1. That's a definition of a greater angle. Okay, so on number 5, going back to number 5, the reason for adding these two angles, so that's going to be the angle addition postulate, which we have learned from our first quarter. And then therefore, using the substitution property for number 7, we can say that the measurement of angle IFG is also greater than the measurement of angle 2, since the measurements of angle 1 and 2 are congruent to each other. And then for the 8th statement, we can say that the measurement of angle 2 is greater than the measurement of angle G using the exterior angle inequality theorem. And lastly, we can say that the measurement of angle IFG is greater than the measurement of angle G using the transitive property of inequality if we go back to statement 7 and statement 8. Okay, for this one. Okay, so therefore we can conclude that our theorem for this one is true. Okay, and then we have the angle side inequality theorem. So what does this theorem tell us? So if one angle is larger than another angle, then the side opposite the larger angle is going to be longer than the side opposite the smaller angle. So let's say, for example, we have here triangle. Let's use a white ink for that one. Okay, so we have here triangle ABC again. Okay, and then we have here side measurements small c, okay, small a, and then small b. Okay, so let's say for example, that we have here, okay, if one angle is larger than another angle, so let's say for example that angle B is greater than angle A. That's our supposition. The measurement of angle B is greater than angle A. According to the angle side inequality theorem, therefore, the measurement of side B is going to be greater than the measurement of side A for this problem. Okay, so let's try to apply that, let's try to prove that theorem using this triangle that we have here. So we have your triangle ARE with line segment RW bisecting angle bisecting angle ARE. So with angles 1 and 3 found in triangle ARW and angle 2 found on triangle WRE. Okay, so for this problem, we want to prove that this side AR Okay, AR is greater than RW. So how are we going to prove that using the angle side inequality theorem? So for the first one, we can say that the measurement of angle 3 is greater than the measurement of angle 2 using the exterior angle inequality theorem for this one. And then for the second statement, we can say that RW bisects angle ARE. So that's a given. Okay, so if we have a bisector there, therefore our third statement is going to follow that the measurement of angle 1 plus the measurement of angle 1 is going to be congruent to the measurement of angle 2. So that's the definition of an angle bisector. And therefore, the measurement of angle 3 is going to be greater than the measurement of angle 1, just using the substitution property of equality. We just substituted that from statement 1. And therefore, we can say that line segment AR is greater than line segment RW, okay, because of the angle side inequality theorem for this problem. Okay. And then we have the Hinge theorem. So the Hinge theorem, we've already seen the Hinge theorem work from the GeoGebra example that we have. But formally stated, the Hinge theorem says that if two sides of one triangle are congruent to two sides of a second triangle, and the included angle of the first triangle has a greater measure than the included angle of the second triangle, then the third side of the first triangle should be longer than the third side of the second triangle for our problem here. So let's say, for example, let's try to apply that. We have here line segment WI is congruent to line segment CA, and WL is congruent to CN. And also, we have that the measurement of angle W is greater than the measurement of angle C for this problem. So therefore, we can say that IL is greater than AN for this figure that we have here. Okay, and also we have here, let's try to solve this one. HO is congruent to OP, and the measurement of EOH, okay, is equal to 21, and EOP is equal to 58 degrees. So is HE greater than PE, less than PE, or equal to PE? So since we have here a triangle that we can use the reflexive property for, so therefore we can say that OE is congruent to OE, and by using the Hinge theorem for this problem, we can say that HE is greater than is less than PE, or PE is greater than HE. Okay, because the 58 degrees here, okay, it has a greater side measurement as compared to the 21 degrees here, also postulated by the Hinge theorem. And then we have the converse for the Hinge theorem. Okay, so for the converse of the Hinge theorem, we have here the measurement of line segment LI is congruent to the measurement of line segment SY. Also for LN and then SB. And also we have another supposition that IN is greater than YB. Therefore, we can say that the measurement of angle L is greater than the measurement of angle S. So this is in opposed to the conclusion that we have here that the measurement of line segment IL is greater than the measurement of line segment AN. Okay, so this is the Hinge theorem, and its converse is going to be for the angles. And of course, for the original one, it's for the side measurements. Okay, so this is the side measurement for the Hinge theorem, and for the converse, it's the angles. Okay, so let's say, for example, we have this problem. PL is equal to 21, UP is equal to 21 on this figure on the left that we have here, and the measurement of angle LPM is equal to 41 degrees, and the measurement of angle MPU is equal to 3x minus 4. We need to write an inequality for the range of the values of x, for the possible values of x for this one. Since we know that PL and UP are congruent figures, and we know that LM is greater than MU, for this one, 15 is greater than 10, and therefore the measurement of LPM, angle LPM, is greater than the measurement of angle MPU, okay, since they are opposites of each other. Therefore, using the converse of the Hinge theorem, we can write the inequality that says that since the measurement of angle LPM is greater than the measurement of angle MPU, we can say that 41 is greater than 3x minus 4, and therefore solving for the value of x, we have here 41 plus 4, that's 45, is greater than 3x, dividing both sides by 3, so therefore 15 is greater than x, or x should be less than 15. And to make sure that our values are not equal to 0, so the 3x minus 4 here, we have to equate it, or we have to create an equation that makes it greater than 0. So 3x minus 4 is greater than 0 for this one. And then 3x is going to be equal to 4, dividing both sides by 3. So therefore, x is going to be equal to 4/3. And that's roughly equal to 1.33 if we transform that into a decimal. So therefore, the range of the values for x, okay, so x should be greater than 1.33, but should be less than 15 for this problem that we have here. Okay, so let's try some problems, and let's try to solve some problems for this one. Let's say, for example, that the measurement of angle 1 is equal to 35, and the measurement of angle 2 is equal to 45. Then the longest side of triangle PQR is going to be, if we're going to add the measurement of 35 and 45, that's gonna give us 45 plus 35, that's gonna give us 80. Okay, so there you go. So therefore, the measurement of angle 1 plus the measurement of angle 2 is gonna give us 80 degrees. Okay, so the measurement of angle 3 should be 100 degrees. Okay, since we're using linear pair postulates, and therefore the side opposite to that. Okay, so this is 100 degrees. If this is 100 degrees, therefore the side opposite to that should be the longest, and therefore the side longest here should be PR. Okay, so let's try another problem. If RP is equal to RQ, okay, and the measurement of angle 2 is equal to 80, then the longest side should be, okay, so we have here an isosceles triangle. If we have an isosceles triangle, so that's gonna give us 180 minus 80, so it's gonna give us 100, divided by 2, that's gonna give us 50. Okay, so therefore the side measurement for the other two angles there is gonna be 50 degrees. And the side with the longest, of course, with the longest part is going to be the opposite of angle 2, which is PQ for this one. And then let's try the third one. The measurement of angle 1 is 90. So the longest side, of course, is going to be RQ. And RP is equal, this is for the fourth one. RP is equal to 8. Okay, this is equal to 8. And PQ is equal to 7. And QR is equal to 5. The largest angle is going to be measurement of angle 3 or angle 3.